Last one, we're going to finish up part 5 here, and I'm going to try and get through this quick. I'm going to have kids start coming in, they're going to be probably super bothersome, but that's okay. I'm just kidding. You know I love you kids. In a totally platonic, not creepy teacher weird way. Anyway, I'm not hurrying at all. We got a particle moving on the y-axis, so you know what that looks like. Here's the axis. We got a particle, just like this. He's moving up and down, whatever. He's just bouncing back and forth, maybe. I don't know. Doesn't really matter. And his position is given by sine of root t. So if you plug in a time here, you find out where the particle is. A says, what's the particle's position after pi squared over 9 seconds? Well, they told you y gives you the position, so all you gotta do is plug it in. So we're going to plug in pi squared over 9 into this thing, and we get sine of the square root of that, and the square root of pi squared over 9 is pi over 3. Well, sine of pi over 3 is root 3 over 2. So its position is, you could think it's root 3 over 2, or if you really want to get down to, brass tacks, I think is a saying there. I don't know if that's dorky. It's probably dorky. It's on the y-axis, so its position is 0, root 3 over 2. Okay, what's the particle's velocity after this time? Well, to find velocity, we need to derive position, because the derivative of position is velocity. And if that's position, y right there, and it's a y because it's on the y-axis, so you get a y value. But anyway, the derivative is going to be velocity. Well, to derive this thing, we use chain rule, so it's going to give us cosine of root t times the derivative of the inside, which is 1 over 2 root t. That's fine. And we want the particle's velocity after pi squared over 9 seconds. So we need velocity at pi squared over 9. And we're going to plug it in, and we're going to get cosine of the square root of pi squared over 9, which is pi over 3, which works out nicely, over 2 times the square root of pi squared over 9, which is pi over 3 again. Cool. So cosine pi over 3 is 1/2 divided by 2 pi over 3. No problem. And when you divide fractions, you multiply by the reciprocal. So this is really going to be 3 over 4 pi. And if we had units, we'd say like meters per second or whatever. That doesn't tell us what the units are in. So there you go. It could be inches per second. We know times in seconds. So it's something per second. But they didn't give it to us, so we don't need to worry about it. If you have units, make sure you write them down. Okay? But that's it. You just plug it into the velocity equation. All right, clear this out of here. Well, we got to remember this. Cosine root t over 1 over 2 root t. Maybe I'll write that again. That was velocity. Velocity was the cosine of root t over 2 root t. Now we want the acceleration at this time. Well, acceleration, this is so simple, it's so nice, is the derivative of velocity. But now we got to do the stupid quotient rule. So, quotient rule says, derive the top, which is negative sine root t times the derivative of what's inside, which is 1 over 2 root t, so I'm just going to make it a little fraction, times the bottom, which is root t. What's up, Taylor? Minus something, oh yeah, the derivative of the bottom. The derivative of the bottom is square root, so we're going to multiply by half, which cancels that to the negative 1/2, so it's really 1 over square root t when you derive that, and then you multiply by the top, which is cosine root t. And all of this is going to be over the bottom squared, which is 4t. And we can simplify it. These 2 root t's are going to cancel, so we have negative sine root t minus cosine root t over root t over 4t. So all I'm going to do here is multiply through this whole thing by root t over root t. There we go. When you multiply that in, we're going to end up with, let me erase some of this junk. There we go. We're going to end up with acceleration is equal to negative root t sine root t minus cosine root t over 4t root t. Alright, so that's our acceleration. That's the best we can do. So Alright, so we got this guy. All we need to do is plug in pi squared over 9, whatever. So we really want, draw. We're looking for acceleration, pi squared over 9. I don't know what this little hand is. Anyway, we're going to get negative pi over 3 times sine pi over 3 is root 3 over 2 minus cosine pi over 3, which is what, 1/2 over 4 pi squared over 9 times pi over 3 is pi cubed over 27. Alright. We can simplify this a little bit, not really much. Might as well simplify that, I suppose. Let's get rid of all this crap. We get negative pi root 3 over 6 minus 1/2, which is 3 over 6. All that's over 4 pi cubed over 27. Same thing as negative pi root 3 over 6, well, minus 3. And we're going to multiply that by the reciprocal at the bottom, which is 27 over 4 pi cubed. So really the acceleration, if you get to the final, actually you can leave it like that, that's just nasty. We'll leave it like that. That's the acceleration. Okay. Let's clear all this stuff out. Asking when the particle turns around is the same thing as asking when the velocity changes sign. So we need that velocity equation again, which was what? Cosine root t over 2 root t. And we want to know where is this thing equal to 0. Well, this thing can only be 0 when the top is 0, when the numerator is 0. So there we go, and we know cosine is 0 at pi over 2, or it's 0 at 3 pi over 2, whatever. We don't know when does the particle turn around for the second time. Well, it's going to be 0 for the second time at pi over 2. So the time is really going to be 9 pi squared over 4. What's up, Sabrina? And that's seconds. And you know it turns around there because, and this would be t equals pi squared over 4. You know it turns around there because you would make your number line. You know the time's going to start at 0. It's going to be 0 again at pi squared over 4. And it's going to be 0 again at 9 pi squared over 4. So, Mr. Ming, and if you check this out real quick, the bottom's always positive. This cosine starts out positive. And once what's inside gets to pi over 2, it's negative. So pi squared over 4 is going to make this pi over 2. It's going to turn negative. It's going to turn positive again. So it changes direction the second time at 9 pi squared over 4 seconds. Okay. What's up, man? Oh, and the answer to this last one, what's the first time interval the particle is moving downward? That's the same thing as having a negative velocity. So that's from pi squared over 4 to 9 pi over squared over 4. So that'd be the answer to E. We'll write that up here. E. It's just from pi squared over 4 to 9 pi squared over 4. And you don't include those because the particle is not moving downward at those times. Its velocity is 0 at those times. Okay.